All right, so the annuity or the accumulation fund. So the formula for the annuities or what I like to call the accumulation fund, when you make regular deposits into an account. All right, so you're going to accumulate a large future value. All right, so you're going to get future value. It comes from making regular deposits, so these would be the monthly deposits. All right, the regular monthly deposits. R is your annual APR, annual percentage rate, divided by 12. Right, because we're always going to break it down over 12 months. And T, remember, is not years. Oh, and I have this down here. But T is, again, the number of deposits that you make all together. I forgot I had it down below on the page. Right, so this is the formula. So there's two versions of it depending on what you're looking for. So if you're looking for how much money you're going to accumulate, it's the first formula, if you make regular deposits. The second formula is if you have a future goal. I want to save up this amount of money over this amount of years. So I want to accumulate this future value. What do I need to regularly deposit at a certain interest rate in order to reach said goal? So again, it's the same formula, it's just solved for two different pieces. The first piece is solved for the future value. The second piece, we know the future value and we're solving for the regular deposits. R and T are the same thing that are in the compound interest cases and the loan cases. R is your annual percentage rate as a decimal divided by N. All right, in this case, N will always be 12 because we're always going to do this monthly. And so this is going to be the monthly interest rate. Again, since we're going to do this monthly, this is always going to be 12 times the number of years. All right, every month for X amount of years. The goal is the future value, the balance after T deposit. T represents the number of deposits that you make as well, right? Every month, for so many years, you're going to make a deposit in the account. So T also represents how many deposits that you make altogether. All right, the goal is the future value, right? After T deposits, the deposit is the regular payments into the account. Again, for us, it's going to be monthly. All right, it doesn't have to be, but we're going to stick to the monthly one since it's the most common one. Just a quick note on this. A lot of finance programs, there's a lot of calculators out there that have finance programs that can do these types of problems. I know the TI-83, 84, Inspire, and some Casios do. I will use the formula in case students do not have these calculators because the formula works in every case. So that if you don't have a program, you can always use the formula, whether you, again, any case, the formulas work. But if you want to figure out how to do them on your calculator, feel free. If you already know how to do that, feel free to do that. But I'm not going to go over that. I'm going to stick to the formulas so that, again, the formulas work for everybody, whether or not you have a fancy calculator or a regular calculator. All right, let's do the first example. Suppose that we want to make a monthly deposit. So every month, we're going to deposit $250 into an investment with an APR of 6% for 10 years. And again, it's compounded. It compounds monthly because every time I put money in, I have more money in there. So it should compound over the same time that I put money in there. All right, find the accumulated balance of the account. So I'm looking for the future value. All right, that's what we're looking for. R is our interest rate. Divide by 12, so 0.005. T is our total payments, which are 12 times over 10 years. So 120 total monthly payments. Right? That's what that T represents. So 120 times we're going to deposit 250 into the account. So again, my deposit, 250. And again, it's monthly. Alright, so the formula, future value is my deposits, 250, times 1 plus R. So I'm just going to go ahead and add 1 plus R is 1.005, raised to the T, so raised to 120, minus 1. You need parentheses around that minus 1. Divide by our R. Alright, so again, the biggest thing is, doesn't get in my way there, is you have to have this set of parentheses around the 1.005 raised to the 120 minus 1. You have to have that set of parentheses in order to get the right answer. All right, when you do, it should come out to 40969.34. So after 10 years, you should accumulate for almost $41,000. All right, how much of the deposit, how much was deposited in the account? So we want to know how much was your actual money, the investor. How much did they actually out-of-pocket money put into the account? All right, well, this would be the total deposits, right? It's kind of like the loan case, the total payments to the loan, right? It's very similar to the loans. Total deposits, which would be T times our deposit. So in this case, 120 times, they made a deposit of $250. So it comes out to, they actually, of their money, they actually invested $30,000 of their money out of their pocket. So, which means what's left over, or the extra, is the interest. So how much interest? Well, you figure out interest by figuring out, you take your future value minus your total deposits. And again, the difference between the two is the amount of interest you earn. So the future value is $40,969.34. They deposited $30,000, so the difference, $10,969.83. So again, they made, right, that's the reason why you invest, not only to save money, but to make money on your money. And so over the 10 years, they were able to make an additional almost $11,000, right, which is no small chunk of change. All right, let's do the second example. So this would be the other way around, all right? So suppose that a young man would like to have $500,000 in his savings when he retires. All right, he plans to retire in 35 years. He will invest money in an account with an APR of 3.5% compounded monthly. How much must he deposit each month into a saving account? So this is his goal, right? Which is the future value. That's the goal, is to have $500,000 in his savings when he retires. All right, so our interest rate is 0.035 divided by 12, which we have to leave that exact. T is 12 times his years, which is 35 years. So T comes out to be $420 months. So he deposits whatever it is when we figure it out 420 times. All right, so this is the other formula. This is when we want to figure out the monthly deposit. His goal, so again the future value, times R, which is 0.035 divided by 12. You have to leave that exact, so if it doesn't give you a nice decimal, you have to leave it exactly as the fraction. All right, divide by, we need two sets of parentheses, the big set and then the little set. So the big set's going to be around the subtraction, the little set's going to be around the addition. So 1 plus the R raised to the 420 minus 1 in parentheses. You have to have the sets of parentheses that I have drawn out here. Again, when in doubt, always extra sets of parentheses, but you have to have them around the addition and subtraction for sure. Okay, so how much does he have to deposit monthly in order to accumulate $500,000 when this is his APR, which again is about what CDs at the bank or individual retirement plans are actually around that 3.5 is what their going rate is about right now. Somewhere between 3 and 4. 4% is what they are, individual retirement plans. All right, when you type it all out, it comes out to $608.12. So every month, for 35 years, he has to deposit $608.12. So again, how much interest? Well, we want to figure out, well, why is this worth his while to do that? First of all, you get to save a little bit at a time, but why? How much interest will he make on his money? Well, interest, remember, is your future value, your goal, minus your total payments. Which, remember, total payments is T times your deposit. So in this case, the future value was $500,000. T was 420. The deposit was 608. 608. All right. So let's first. I'm gonna actually figure out how much they had first before we go ahead and do the subtraction. So I'm gonna take my 420 times my 608.12. 410.40. All right, so he actually deposited $255,000, $410.40 altogether. That's how much of his money is in the account at the end of his, 35 years. But he gets $500,000 because he earned interest every month of those years as well. And so he actually doubled his money almost. Close to doubling his money, right? When you take the difference here, it's almost doubling, pretty close. This is how much money he made in his retirement plan. All right, so again, he accumulated about half the amount himself. The other half of the $500,000 just came from the fact that he invested it into an account guaranteeing him a 3.5%, which, like I said, at most banks, if you take out a IRA is what they're called. If you take out an IRA, that's about what the going rate is about 3.5% on your IRA. The thing is you can't touch it. All right, when you open up an IRA, you put money into it, but you can't take money out of it until what's called it graduates. So usually you set it down there for so many years, and you can't touch it until the end of so many years, which is around usually 30 years, or retirement age. It's an age thing too. It can be around 60, 65 is when you can pull your money out. All right, which again, we're going to get to retirement, so that's the next set of notes. All right, stopping there. So that's a couple examples of the 2 different ways that you can do the accumulation fund. Stop there and pick up the next set of notes in the next video.